Hey geometry, so in this video we're going to look at more advanced tangent problems from that introductory video. So I'm going to show you a couple problems here that kind of take tangent lines a little bit further, and then I will have a set of more challenging problems for you to try. So here I have, I'm given that line BC is tangent to circle A, and I want to find X, our radius. Okay, so I do, since I know this is tangent, BC is tangent, I do want to make sure that I label that as a right angle there. And now look at my right triangle. So in my right triangle, let's put our Pythagorean theorem here. I know that A, honestly, it does not matter which side, use it as A or B. Remember, I'm just going to use A as X. So I know that X squared is going to be A squared. 15 squared will be B squared. And now, how do I express, or how am I going to express AC as a whole length? Well, no matter what this value is, the way I'm going to figure out the entire length is by finding the sum of these two values. And I can actually express that using X as X plus 9. And that's my C, so I need to square that. Okay. So a little bit of work here because 15 squared, 225. Now, don't get tripped up, right? We're not going to be squaring the X, squaring the 9. Whenever I square a quantity or a value, I'm talking about that being multiplied by itself. So I need to do a little bit of what you know is foiling here. Okay, so I've got X squared plus 225. All right, so now I'm gonna distribute both the X and the 9 to both these terms. So X times X is X squared plus 9X plus 9X plus 81. All right, and I can combine those two to be X squared plus 18X plus 81. All right. So if you're in Algebra 2, you should know this already. If you're in Algebra 1, you are literally learning it within the next few weeks. So now, something you should notice here, I have an X squared term on both sides. That's actually just, I can cancel those out, right? Because if I would subtract that away, that would eliminate both the X squareds. And that is going to save me from having a quadratic that I have to solve here. All right, so we're doing 225, take away 81, and then we're going to divide by 18. So 225, take away 81 is 144, equals 18x. And 144 divided by 18 actually ends up being 8. So x, I'm off the camera here, x in this case ends up being 8 centimeters. All right, two more problems. So here, I've got a tangent line AB. I know that's a right angle, right? And then I also have a couple connections here, another radius, these two radii. So if this is 2 centimeters, then I know this is 2 centimeters, right? This is 8, this is 8, okay? So the key for this type of problem is I'm going to create a right triangle by constructing this parallel line to the tangent line. Because if that line is parallel, now I know that this is also 90 degrees, and I have now, and this is going to be X centimeters long, and I've now created, let me highlight this right triangle within here that I can work with now. So if I extract that right triangle, so be careful here because I almost wrote that as 8 centimeters. That's not going to be 8 centimeters anymore. This whole length is. This piece is 2, right? That translated. I've just created a rectangle down here. So therefore, I'm left with 6 centimeters there. Okay. I've got this guy is this whole length. So 8 plus 2 is 10, and then x here. All right, and then I'm not going to bother going through the Pythagorean theorem. Hopefully you guys are able to recognize that triple, 6, 8, 10. So x in this case is going to be 8 centimeters. All right, and then the last problem here is we're going to actually use proportions to do this. So I have CD is tangent to both of these circles. Okay, and so if you can see, I've got two triangles here. I'm going to highlight them separately. So I've got two right triangles specifically. This larger one, and then this smaller one inside of that. Okay, and so I'm going to compare those lengths because those triangles are similar. Why are they similar? Well, by angle, they both share this acute angle down here, and they both are right angles. So by angle, those are similar. So I know the sides are proportional. So I can create a proportion saying 6 compares to 4. The same way that, so remember, I have to use the whole side of this triangle. X plus 10 compares to 10. Okay. So if I pull those triangles out, just to make sure you guys see this, there's the larger one, there's the smaller one, right angles. So this was 6, this was x plus 10, this was 4, this was 10. So I did 6 compares to 4, the same way x plus 10 compares to 10. All right, and then here I can do some cross multiplying. So I've got 60 equals 4x, don't forget to distribute that 4, plus 40. I'm going to subtract that 40 from both sides. 4x equals 20. So x is 5 centimeters. So this guy here ends up being 5 centimeters. All right, so the practice problems for this set is that some of them are challenging, but give them a shot because they're good problems.